Alright, so I wanted to do a very abbreviated tutorial on my methodology behind predicting lift and good soaring days. I'm not going to go into any of the mechanisms here or explain anything in any kind of depth. If you want to understand that or want to really get a sense of how to do this on a better level, I really recommend you go through each of the 6 parts of my longer tutorial about predicting lift. But I'm just going to give you a real cut to the chase version of how I do it. And basically what it is, or what I'm looking at, is soundings, which are graphs of how temperature varies with height. And the way I'm going to get the data is through computer models, and one site for this is twisterdata.com. It's probably, there are some better tools that I like a little more, but this is the quickest way to get it without having to install any kind of software. The 3 models it has are the Rapid Update, the North American model, and the Global Forecast System. Those buttons right there at the top of the screen. More than 84 hours out, if you want to know if you're going to have a good soaring day, your only option is the Global Forecast System. If you're looking within 84 hours, the North American model is another option. The Global Forecast System does short-term too, but so does the NAM. The NAM is a little higher res, but overall they'll usually agree in terms of their output. And the Rapid Update has hourly resolution as opposed to 3-hourly resolution on these for 18 hours in advance. So that would be if you're looking at like the day of, you want to see if there's going to be good lift. Anyway, so let's just stick with the GFS for now, because we're going to be looking at some, long-term conditions here. And anyway, you click on any of the models and you'll get a map of the US. And just click where the location you want for a sounding. Once this loads, well, the image didn't load yet. There we go. You can adjust the point. You might not get it exactly right. So let's just go with the middle of the island and just say plot new sounding. So the model runs itself several times a day. In other words, the computer model takes the initial conditions around the globe and predicts what will happen. It does this a few times a day. And one of the things you want to look at, these are the hours from now. So in other words, this sounding we're looking at here, this predicted sounding, this is as of current, as of 0 hours. That would be the initial time, right now basically, and we can go ahead 3 hours ahead, 6 hours ahead, 9 hours ahead, and so forth. And you see the red, that means the model hasn't completed the run. So you might want to go over here to the top corner and select a previous run of the model. It's only about a 6-hour difference, and there you go, you can see this run is complete. It's all green here. And basically, you can see the time on top that it gives you. Don't forget to convert that to Eastern time. But again, all you need really to predict lift is this graph. I'll show you how in a second. But to navigate to a different time, it's all these controls here. So if we go to 0, for instance, that's 18Z this afternoon, or 2 p.m. And then let's say we want to look for 2 p.m. tomorrow. That would be 24 hours ahead of now. So this is our forecast sounding for 2 p.m. tomorrow, which it says on top there, for this location. So that's how to navigate through the data on this site. Anyway, how to interpret the soundings. All right, so let's say we do want to fly tomorrow afternoon at 2 p.m. And we have this graph. Basically, the trick is to look for the temperature line, which is the red line here, to be decreasing at the dry adiabatic lapse rate, which is that line right there, or these slopes. You're looking for the red line to parallel the slopes, which signals a good mixed layer, which signals usually good thermals. Now I happen to know that if we go to hour 174 here, this is like a week ahead. Yeah. Okay. This is a week ahead of time because the pattern we're in now is pretty cloudy and not, we're not getting a lot of solar heating. But out a week in advance, the model is predicting some pretty good lift here. You can see exactly what I just talked about. This red line following the slope of these dry adiabats. See that? So this red line follows the slope of that. So that signals good lift right up until about there, where the slope does not any longer follow the dry adiabatic lapse rate. And so you can look and see at about what height that is. And these are in meters, not feet. So you'll have to convert and kind of interpolate between the two heights. But that's how you would basically predict the height of the mixed layer, or the height of which you can expect thermals to be rising to. Now this is a really good day, which is why I picked this one to look at as an example. They're not always going to look like this. So again, this is about a week ahead of time now. And this is just predicted. This did not occur or anything. Let's go back to the one a day in advance, 24 hours from now. You can see we are not getting any lift really. This temperature profile does not follow that dry adiabat at all. Let's go another day in advance, so 24 hours. And we could look at, night times, early mornings, but ideally 2 p.m. is a pretty good time to fly. Mid-afternoon, that's when thermals are booming. Alright, so 24, let's go to 48 hours here. So this is now 2 p.m., 2 days away. And again, it doesn't really look like good soaring conditions because we're not seeing that dry adiabatic lapse rate. Let's find another example. Okay, so here's one that this isn't as good as the first example I showed you because the dry adiabat isn't reaching as high, but it's still there. So you predict good lift in this part of the atmosphere, the part where the red line follows this dry adiabatic lapse rate. You can kind of see the height it goes to, around 1,600 meters or so. Anyway, so this is Long Island. If we want to make this interesting, we can let's go to another part of the country. Let's go to Arizona, where, it's deserty. Alright, you can see pretty clearly there is no problems getting lift there. By the way, if you see at the surface a line that's even steeper than these dry adiabats, that's really good. That means the parcels here at the surface are going to really rise. So, looks like there's good lift all the way up until that height. Whatever that is. You can see these boundary layers, these regions of the air that support thermals over the desert, really, really high. So, hope you enjoyed that quick tutorial. And again, for a more in-depth understanding of how this works and for some more tips on how to do this, I recommend you look at my full tutorial.